Here are your doodle notes for topic 1, lesson 3. This is going to start on page 24. Okay, so whenever you're going to be taking notes, the best thing to do is just kind of flip through whatever you're reading just to kind of see where the lesson's going to take you. Okay, so when I'm looking at this, I've got physical changes in matter, and so these are kind of subtopics of that. Turn the page, that's still subtopic of physical changes in matter. This one's a nice red, so this is a new concept. So now it's chemical changes in matter. Some subtopics here. Energy and matter are related, and then some subtopics in there. Okay, so I know that I've got 3 main things that this lesson is going to be about. Energy and matter are related. Chemical changes, and physical changes. So when I set up my doodle notes, okay, I've got 3 main ideas. So I'm going to set this up with physical changes, chemical changes, energy, and matter. So I've got those 3 sections, okay? So I'm just going to start reading. So physical changes alters the form or appearance of matter, but does not turn any substance in the matter into a different substance. Okay, so I'm just going to move this over here so it's easier. Okay, so starts with physical changes and that definition. Okay. Just going to zoom in. Maybe. Okay, so if you accidentally drop a glass onto a hard floor, the glass may shatter. However, the chemical composition of the broken glass is still the same. A substance that undergoes physical change is still the same substance after the change. Okay, so they do a broken glass example. Here's my glass. It broke on the floor. This is a physical change. Okay. So then I read the next section, changes in state. You have learned that most matter exists in 3 different states, solids, liquids, and gases. Suppose you leave an ice cube in a glass and forget about it. When you come back, there is a small amount of water in the glass. The ice cube has undergone a physical change. The solid water that made up the ice cube has melted into liquid water. A change in state, such from a solid to a liquid or from a liquid to a gas, is example of a physical change. Okay, so I'm going to go back to my notes. States of matter. So we know that states of matter are solid, liquids, and gases. A change in state is a physical change. So if we change between any of these, that's a physical change. So I drew my ice melting because that's going from a solid to a liquid. Okay, and this is all under my physical changes topic, that area. Okay, so then, if I go to the next page, changes in shape or form. So when you combine 2 substances, how do you know if just a physical change occurred or whether you have created an altogether new substance? There are ways to figure it out. For example, imagine that you pour a teaspoon of sugar into a glass of water and stir until the sugar dissolves. If you pour the sugar solution into a pan and boil away the water, the sugar will remain as a crust on the bottom of the pan. The crust may not look exactly like the sugar before you dissolved it, but it's still sugar. Therefore, dissolving is a physical change. Okay, so on my doodle notes, okay, I've got sugar and water. I heat it up and evaporate the water off, only sugar is left. Okay, so that's one way I can tell that a physical change has taken place. So I'm going to write up here, dissolving is a physical change. Okay. So then, if we go back to our next paragraph, one example or other examples of physical changes include bending, crushing, breaking, and carving. Any change that alters only the shape or form of matter is a physical change. Methods of separating mixtures such as filtration and distillation also involve physical changes. Okay, so that's where I drew on here other examples. So bending, crushing. So this is a mortar and pestle. We're going to crush whatever those little pieces are. So we're going to crush those up. Breaking, this is something that was broken. Carving, so this is supposed to be like a wood carving tool, carving a little chunk of wood off. So that's what I did for my doodle notes, okay, for those physical change section. Okay, so the next section is that chemical changes in matter. A change in matter that produces one or more new substances is a chemical change or chemical reaction. Okay, so that's where we start. We've got this middle section. Remember when I previewed the lesson, the middle section I had chemical changes. And so then I'm going to write that definition here. A change in matter that produces one or more new substances. So when I continue reading, in some chemical changes, a single substance breaks down into two or more other substances. For example, hydrogen peroxide breaks down into water and oxygen gas when it's poured on a cut on your skin. In other chemical changes, two or more substances combine to form different substances. Photosynthesis is a natural chemical change that occurs in plants and other photosynthetic organisms. Several compounds are combined using energy from the sun to produce new substances. Okay, so we've got some of those changes going on. We've got photosynthesis. Okay, this is where we're combining, so several compounds combine to form new substances. That's a chemical change when a new substance is born or made. And then I have hydrogen peroxide is going to break down into water, and then it also said it's going to break down into oxygen. Okay, all right, so then we're going to continue reading. Some chemical changes can be initiated and observed in the kitchen. If you have ever baked bread with help from yeast, you have seen a chemical reaction at work. The yeast reacts with sugars in the mixture to produce bubbles of carbon dioxide, which make the dough rise. Another chemical reaction takes place on the surface of the bread. As heat is added, the sugar turns to a brown crust. Okay, so this is the example down at the bottom of your page. If you wanted to, you could draw the bread in your doodle notes and talk about producing those gas bubbles. Okay. All right. So then we move to the next page. Examples of chemical change. One common chemical change is the burning of natural gas on a gas stove. Natural gas is mostly made up of the compound methane, CH4. When it burns, methane combines with oxygen in the air to form a new substance. The new substances include carbon dioxide gas and water vapor, H2O. Both of these substances can be identified by their properties, which are different from those of methane. Figure 4 describes some types of chemical changes. Okay, so in my doodle notes, okay, I have the burning of natural gas. So we have CH4. It forms the new substances, carbon dioxide and water vapor. Okay, so then that paragraph mentioned the figure. So it's always good to look at the figure. So tarnishing is the slow combination of a bright metal, such as silver with sulfur. Oxidization is the combination of a substance with oxygen, such as when iron rusts. Objects catch fire. Okay, so when a fuel combines rapidly with oxygen, producing heat and light and new substances, and then bubbles are created by using electricity to break a compound down into elements and simpler compounds. So, these are all signs of chemical changes. Okay, so that first one was tarnishing. The second one was rusting. Okay, then we had the fire, so burning. And then finally we had the bubbles, okay, or gas is created. Okay, so these are some of the clues that we would have that a chemical change has taken place. All right, so if I go back to my book, now the book starts with energy and matter are related. So we've done the chemical change and the physical change sections. Now we have that last section. Okay, so energy and matter are related. Do you have much energy for schoolwork today? In science, energy is the ability to do work or cause change. Any kind of change to matter involves a change in energy. Bending a paperclip or chopping an onion takes energy. When ice changes to liquid water, energy is absorbed and from the matter around it. Okay, so that, if I go to my doodle notes, okay, so this is my section topic, energy and matter, okay, and then it says any kind of change in matter involves a change in energy, okay, and then it went into talk about bending a paperclip takes energy, and melting ice absorbs energy from its surroundings. Okay, so I drew the energy going in. So anytime you have some kind of a change, energy is involved. Okay, so then we've got this little paragraph right here. Like matter, energy is conserved in a chemical change. Energy is never created or destroyed, it is only transferred. So that's kind of an important point. So I put energy is conserved, energy is not created or destroyed. Okay, so now we're on this paragraph down here. Temperature and thermal energy. When you walk into a warm building on a cold winter day, you will immediately notice the difference between the cold outside and the warmth inside. We refer to the measure of how hot or cold something is as temperature. Temperature is related to the motion and energy of the particles of matter. The particles of gas in the cold outside have less average energy of motion than the particles of the air inside the warm building. Okay, so from that, I wrote, temperature is how hot or cold something is. It's related to the motion and energy of the particles. So I drew cold air, less energy, so those particles aren't really moving, okay, because it says related to the motion. And then warm air, those particles are moving faster, so that's more energy. Okay, so then we're right here. The total energy of the motion of all the particles in an object is known as thermal energy. We usually talk about thermal energy in terms of how hot or cold something is, but thermal energy is not the same thing as temperature. Thermal energy naturally flows from warmer matter to colder matter. Okay. All right, so for my notes, here I wrote thermal energy, the total energy of motion of all the particles in an object. Okay, so now we're here. When matter changes, thermal energy is usually released or absorbed. For example, ice absorbs thermal energy from its surroundings when it melts, leaving the air around it feeling cold. That's why coolers for food and drinks are filled with ice. The melting of ice is an endothermic change, or a change in which energy is absorbed. Exothermic change occurs when energy is released. Combustion is an exothermic change. Okay, so I added a few things on my doodle notes. Okay, so when matter changes, thermal energy is released or absorbed. Okay, that last sentence, combustion is an exothermic reaction, energy is released. Okay, and it also talked about melting ice. That's an endothermic reaction, energy is absorbed. That's what that melting ice, that energy is going in. So those are what I drew on my doodle notes. Okay, and then we have one last paragraph. Chemical energy is stored in the chemical bonds between atoms. Foods, fuel, and even the cells in your body store chemicals. Burning fuels transforms chemical energy and releases some of it as thermal energy. When you ride a bike up a hill, chemical energy from food changes into the energy of your muscles' motion, which your legs convert into mechanical energy through the bike pedals. Okay, so the only thing I wrote down for that one was chemical energy is stored in the bonds between atoms. And that is the end of that lesson for doodle notes. I'm going to zoom out a little bit. Okay, so you can kind of see, I'll be tracing over this with my black Sharpie and coloring it in, making it look nice with all the rest of the stuff.